After 40 years of studying theoretical physics and working on string theory, I have learned to recognize moments when the universe is preparing to reveal one of its greatest secrets. And now is exactly such a moment. Right now, as you listen to my words, an ancient traveler from interstellar emptiness, an object officially cataloged as 3, I-Atlas is racing through our solar system at a speed that makes even a theoretical physicist hold their breath. 60 kilometers per second. This means that in the time you spent on a cup of coffee, this interstellar guest flew the distance from Moscow to St. Petersburg. In my research on multidimensional physics, I often speak about how our three-dimensional reality is merely a shadow of a more complex picture of existence. And 3I-Atlas is living proof of this idea. This is not just a comet. This is a mobile laboratory carrying information about processes that occurred before the birth of our sun, when our galaxy was very young. Back in July, we noticed it as a faint glimmer, a barely distinguishable dot against the cosmic background. But the laws of physics are relentless. When interstellar matter encounters intense solar radiation at speeds thousands of times faster than sound, something truly magical happens. Frozen gases awaken, creating a glowing envelope that transforms an ancient rock into a shining beacon. Let me explain with a simple example what's happening to 3I-Atlas. Imagine an ice cube that you threw into boiling water, but this ice is flying at the speed of an intercontinental missile, and the boiling water is the most intense solar radiation. Molecules don't just melt, they tear apart into atoms. Atoms lose electrons, creating plasma. This plasma interacts with the sun's magnetic field, forming structures that extend for millions of kilometers. In the context of string theory, which I have devoted most of my career to, such extreme conditions allow us to glimpse processes occurring at the fundamental level of reality. When matter undergoes such energies, effects manifest that are usually hidden from our eyes. As a physicist, I admire how humanity has turned limitations into opportunities. When our Earth-based telescopes are blinded by sunlight, Mars becomes our observatory. Imagine, we, microscopic beings on a tiny planet, have built a network of robot observers on another world. This is a triumph of human reason over the limitations of space and time. On October 3rd, something amazing happened. Our robot geologist Perseverance captured a diagonal streak cutting through the starry sky of Mars. In the context of my research, this resembles a particle track in a bubble chamber, an instantaneous imprint of fundamental forces of nature in action. 9 minutes of exposure, stacked images, mathematical processing, and here before us is proof that an ancient rock from another star system flew through our Martian ambassador's field of view. The European Space Agency has deployed an entire armada of observers. Mars Express and ExoMars Trace Gas Orbiter work like cosmic detectives, gathering clues about this alien's chemical composition. American orbital stations. Mars Reconnaissance Orbiter, with its stunning high-rise camera and atmospheric monitor, MAVEN complete the picture. Even China's Tianwen-1 and the UAE's HOPE can contribute if their operators manage to deploy instruments quickly enough. But the most intriguing began in September, when 3I-Atlas crossed the threshold of 2 astronomical units from the Sunday. Suddenly, its brightness began to grow faster than our models predicted. In science, such anomalies are the most valuable moments. They tell us, your theories are incomplete. Something new is hidden here. Now the comet shines at magnitude 12. For cosmic scales, this is quite bright. Any owner of a decent amateur telescope can observe it. But it's not that we can see it, but how it shines. Spectral analysis shows mysterious green glow. This could be classic carbon molecule emission, so-called swan bands, or it could be something completely new, the result of plasma processes we don't yet fully understand. What we're observing is a physics textbook written by the universe itself. When 3I Atlas reaches perihelion between October 29th and 31st, it will find itself in extreme conditions where the laws of thermodynamics, electromagnetism, and quantum mechanics will manifest simultaneously. Speed will increase to 68 kilometers per second. This is comparable to flying from Earth to the Moon in 3 hours. At such energies, even the most stable molecular bonds begin to break, creating plasma flows and ionized gases, a true demonstration of what I call the symphony of fundamental forces. Imagine an object the size of a small city, racing at speeds where the kinetic energy of each kilogram of its mass is equivalent to the explosion of a ton of TNT. When such a mass encounters solar radiation, its surface temperature rises to thousands of degrees. Matter doesn't just evaporate, it ionizes, transforming into the fourth state of matter, plasma. On October 21st comes the moment astronomers call superior conjunction. The Sun will stand exactly between 3I Atlas and Earth. From our perspective, the comet will disappear in the solar rays. This reminds me of the observer paradox in quantum mechanics. When we cannot observe a system, it seems to cease existing for us. But here's the irony of modern astronomy. We can photograph the shadow of a black hole in the center of another galaxy. We can detect gravitational waves from colliding neutron stars a billion light years away. But a simple rocky object near Mars can completely disappear from view simply by being on the same line with the Sunday. After this blind zone, the most interesting will begin. The European Space Agency's JUICE spacecraft will take position for extended monitoring. It will have a unique opportunity to observe 3I Atlas from a different angle, from deep within the inner solar system. In my books, I often write about how science moves from impossible to inevitable. In less than 10 years, we have encountered 3 confirmed interstellar messengers. Oumuamua arrived first, followed by Borisov, and now 3I Atlas. Each destroys our conventional expectations and opens new horizons of understanding. Oumuamua amazed us with its cigar-shaped form and mysterious acceleration. Borisov turned out to be a more ordinary comet, but it came from a completely different star system. And 3I Atlas teaches us how sleeping matter activates under solar radiation. Perhaps in a few decades, such encounters will become commonplace. But now we're experiencing a historic moment, the time when humanity takes its first steps toward understanding what lies beyond our cosmic home. When 3I Atlas disappears behind the Sun at the end of October, then returns in December, transformed by its journey through the solar furnace, we will receive data that will enter future textbooks. Comparing before and after images will show us how extreme conditions change the structure of interstellar matter. And perhaps these very observations will bring us closer to answering the question that has troubled me throughout my scientific career. Does there exist a unified theory explaining all laws of nature? Each such interstellar guess brings us a piece of this great puzzle. In a few years, some graduate student will write a dissertation beginning with the words, "Study of Object 3. I Atlas allowed us to understand." This work will mention Martian observations, the diagonal streak in Perseverance images, the mysterious brightness anomaly at 2 astronomical units, the emerald glow of the gas envelope, behavior during perihelion passage. This is how the history of science is written, not with loud declarations, but with painstaking work, precise measurements, and willingness to accept what contradicts our expectations. The universe is not obliged to be simple to understand, but it is obliged to be consistent. And in this consistency lies the key to understanding our place in infinite space. And while 3i Atlas continues its ancient dance with our sun, we, inhabitants of a small blue planet, carefully observe and learn